All right, welcome everybody to the Sail Code Crafters Meetup. We are a diverse group of people who believe in quality code practices and processes. We're language and technology agnostic. So everybody's welcome here. We are going to actually have a really nice talk with great slides from what I hear today. Jacqueline Bilston is going to talk to us about, I had it, where'd it go? What are you going to talk about, Jacqueline?
Testing ETL pipelines or testing data pipelines, depending on how you know of them.
Awesome. We just met, I think, right? Just today. But now the more you talk and the more people are like, oh, I had to come because Jacqueline's here. I'm like, I had to go look to see whether I follow you on Twitter, and I haven't been able to figure that out yet. So I will.
My handle is in all of my slides, all of my excellent slides. So you can find it there.
Excellent. And so you work at Yelp, and you said you'd been there for about a year, somewhere in that area?
Just under a year. October 12th is my 1 year.
Right. And this is the first time you worked with data, and you said that like 3 months after you started, you decided to submit a talk to a conference so that you would just.
It wasn't supposed to actually get accepted.
Uh-huh.
I submitted the talk because I was like, maybe I want to talk at some point, and I should know how much effort it is to submit an abstract and everything. And then it got accepted.
Fabulous. And it went well.
Oh, it did. Yeah. It went really well. They told me, like, lots of people told me it was their favorite talk at the conference, which is kind of cool. Yeah.
Excellent. So I'm gonna let you take it away. And do you want to have questions at the end? Questions throughout? Questions
at the end would be pretty cool. If we
okay.
Do that. Thank you.
All right, we will do that. So go ahead. Let's hear what you got.
Perfect. So good morning. I'm Jacqueline Bilston. I am a software developer working in data engineering at Yelp. I also run the Calgary Software Crafters, which is a group of developers who get together once a month, kind of at meetups like these, to talk about quality code and stuff, which is cool. We also do katas together, which is really fun. And today I'm going to tell you the story of how I learned to effectively test my ETL pipelines. And these are my talk resources. So if you're the type of person that likes to wait until the end of a talk to download the resources, I have this exact same slide up at the end of the talk. But if you like to download the resources beforehand, they're right here. You can use that QR code with your phone. Our story begins with a frog. This is a Xenopus frog, and it's important for our story because it's responsible for the very first time that I ever came into contact with anything that resembled an ETL pipeline. For my first job out of university, I was a bioinformatician. And it was my responsibility to extract genetic and genomic information about this frog from labs around the world, transform it into a format that our genome browser could understand, and then load it up into our genome browser so that scientists from around the world could use it to make scientific discoveries. And that's what ETL stands for, is extract, transforming, and loading of data. The year that I graduated university, the Nobel Prize in Medicine was won by a Xenopus researcher. I was so excited to be part of this important research, and I really, really wanted to do a good job. Unfortunately, I made a lot of little mistakes. And every time I found a mistake, I would need to go into the code and fix it, and then manually set up and rerun the affected section of the pipeline in order to make sure it was really gone. And in the process of fixing and setting up and rerunning the pipeline, I might miss a few steps or set things up the wrong way. And so that section would fail, or it would look like the bug was gone when it was actually still really there. So I would need to go in and fix things and do it all over again. Or I might think that I'd fix the bug, or I might actually fix the bug, but break something earlier on in the pipeline. I was essentially a junior developer with very little mentorship at this point, and I didn't know about automated tests. All that I knew was that I was slow and I was letting my team down. But when I found out about automated tests, when I found out that I could get a computer to do all of this work for me, I felt free. A computer will run the steps in exactly the same order every single time. And computers can run the steps in parallel, so you can test multiple sections of your pipeline all at once and know if you've broken anything. And when I came to Yelp and we had 100% test coverage in the areas of the code that we were working on, I felt like I'd found my people. I was so excited. I was never, ever going to be slowed down by a stupid little mistake ever again. This is a bug. It's not a real bug. It's actually one that I've invented so I can share my code with you. It's in the talk resources if you guys want to look at it afterwards. But it is definitely based off of bugs that I've experienced at Yelp. And like all of the best bugs, it happened on a Friday afternoon. A data scientist named Jenna came to me and said, the number of interactions in the pandemic recovery table doesn't look right. And I was like, oh, because we had 100% test coverage of the code that generated this table. And all of our tests were passing. And none of our automated tests were telling us anything was wrong. But Jenna is the type of data scientist who has like a sixth sense for her data. She has an intuitive understanding of its shape and what it should look like. And if she says something is wrong, well, we better check it out. So I did. This is the pandemic recovery table. It's a table that we use to track the recovery of small businesses throughout the pandemic. And we do that by counting the number of interactions users on Yelp have with those businesses per day. This is we do that by adding up the number of reviews, check-ins, or tips that somebody might leave about that business. And we add those up into this interaction count column. Now, what Jenna said to me was, this is where she'd noticed the bug. The number of interactions was incorrect. And it was incorrect because, not because we were adding things up wrong, but because the number of reviews was wrong. At that point, she said, I don't know how we're calculating these reviews, but you better check it out because something's up. This was a problem because we weren't the end users of this data. We had multiple downstream teams that relied on it. And we had to go to all of them and say, there's an issue with this data. We don't know what's wrong. We don't know when it will be fixed, but you need to stop using it for now. I don't know if you've ever had to have a conversation like that with any of your customers, but it is not fun. So we dove in as a team to investigate what the issue could be. There was just one problem. This is a diagram that one of my teammates made of about 1/2 of the pipelines that we maintain at Yelp. We knew where the buggy table was. Oh, sorry. We knew where the buggy table was, but it could have been caused by any of our upstream jobs. And because all of our automated tests were passing, we had no idea where the issue would be. So we had to manually dive in and investigate the code to try and find the issue. It took us 5 days to find that bug. And once we found it, it took us another 3 days to fix it because we couldn't trust our automated tests. Our automated tests were passing. They weren't catching the bug. So we had to manually set up and rerun that pipeline to make sure we'd really gotten rid of it. The most frustrating part is that it was a one-line fix. This is the review screen for on the Yelp app. And on this screen, you have the option to check in. And if you check in, we increment the check-in count column. And you also have the option to leave a review. If you leave a review, we increment the review count column. Because these buttons are so close together, lots of people were going to businesses, checking in and leaving a review at the same time. And our product owners said, well, that's not two interactions, that's one. So they asked us to remove any mobile reviews that matched a check-in. We knew what we wanted. It was a left anti-join. This would remove any check-ins any mobile reviews that match check-ins on user ID, business ID, and date. Unfortunately, there is another type of join you can do in PySpark. It's called an inner join, and it's the default. The difference between these two joins is one parameter, and that's what we've left out. Not only did it take us 5 days to find the bug and 3 days to fix it, we had to then spend 7 days running backfills for 2 months of bad data. This was frustrating. And it was a big deal. It was a lot of lost time. So I decided to take a look at my tests to see if I could figure out why they hadn't caught the bug in the first place. When we test data, we had 2 layers of tests that we use. The first layer is something that I call data tests. It's kind of the equivalent of what I would call monitoring in application code. This basically checks your data in production to make sure that it conforms to a certain set of rules. It'll identify duplicate values or nulls that shouldn't be there, or something that's completely outside of the realm of possibility. I didn't expect these tests to catch this bug because the values, they weren't obviously wrong. They weren't violating any obvious rules. They just were wrong. The tests that I expected to catch the issue were our logic tests. Now, the logic tests are what most people would call unit or integration tests in the application context. They verify that for an input, your code logic is producing the correct output. And when I dove into these tests, I noticed something really weird. They weren't just not catching the bug. They were actually testing for the buggy behavior, which was really wrong. And I didn't know why that had happened, and I was stuck. Thankfully, when I'm stuck, I have a wise old developer I can ask for help. If Uncle Iro existed in real life for code, his name would be Jay Bazuzzi. Jay is a principal developer at Tableau, and he is one of the smartest people I know, as well as legitimately caring about building up a community of software developers who care about each other and support each other. So I went to Jay and I said, Jay, I don't know what's wrong. This test should have caught the bug, but it didn't. Can you give me some guidance on what could have happened? And Jay, being Jay and a lot like Uncle Iro, answered my question with a question. What bug are you trying to catch? I said, Jay, I don't think you get the point here. The whole reason I have tests is so that I don't get bugs. They're supposed to catch all of the bugs. What do you mean? What bug am I trying to catch? This makes no sense. And Jay sort of nodded at me wisely and told me to go away and think about it for a little bit. So I did. This was our logic test here. You'll notice I said one test. That's because PySpark is the tool we're using for our data pipelines, and it's really great at analyzing large data sets in a distributed context. But when it comes to looking at small pieces of data in a local machine, like you would for a unit test, the coordination overhead makes it really, really slow. So we tried to get past that by writing one big test for everything. And we basically had a bunch of JSON files with individual rows that we converted into data frames and then provided those into our transform function. Now, the rows in the JSON files would cover every single test case for what we thought would be important behavior. Once the transform function read those data frames in, it would produce a data frame that we would then convert back to JSON and compare to a very large expected JSON file. And this was where the problem was. This was the state of the file at the point where I added my feature. It had about 40 or 50 different rows in it. It was a lot of test cases. So when I changed my behavior and I wanted to see what the difference was or how the code had changed, the output had changed, I had to use a large diff. And I knew what the rows I'd added were supposed to update to. I could take a look at the old values here and compare them to the new values and check that the numbers were updating the correct way. But I wasn't about to do that for 50 different test cases. But you know, I could see that the number of reviews and the number of interactions were the only values that were updating, and they sort of seemed to look right. So I did what any good lazy developer does, and I uncommented the script, the override expected actual data frame script at the bottom of my tests. I'd written the bug into my tests. I went back to Jay and I said, okay, Jay, you were right. This test was testing too many things and it was impossible for me to catch the important behavior. But all I have is this big test. Like, how do I make it smaller? How do I make it more specific to what I care about? And Jay, being Jay, answered my question with another question. Have you ever heard of a SAF squeeze? I said, no, but this time I'm going to be a good student and I'm going to go find this out for myself. At the time that we had this conversation, the SAF squeeze was present in 2 places on the internet. The first was an obscure Stack Overflow post, and the second was Kent Beck's original blog article that he'd written when he worked with David Saf in 2008 on the JUnit project, but it was preserved on the Wayback Machine. So from these, I sort of gathered that a SAF squeeze was a way to find a bug with automated tests, but I didn't know how it was relevant to my case because we'd already found and fixed the bug. I didn't know what I'd want to do with it. So I asked Jay if he could take a little bit more time and explain it some more to me, and he did. The SAF squeeze is definitely a way to find bugs with automated tests, but it has a really cool side effect. And that is, you know, when you do a SAF squeeze, you write an assertion that's super specific for the bug that you're trying to catch. And then as you try to find that bug, the SAF squeeze actually reduces your test down to the minimum amount of code that you need in order to reproduce that buggy behavior. Now, if you've already caught the bug and fixed the test, you can actually still write a specific assertion. It's an assertion that's specific to the behavior that you care about. So I thought, well, I can do that with my test. I'll try it. The first thing that I did was I duplicated it. And that's because the test is still there. It's still providing me value. I don't want to lose it. And then I was like, I'm going to go into that large integration test and maybe give it a better name. Test will do the right thing is not a great name for a specific test. It's great if it's testing everything, but if it's testing a specific thing, you want to give it a good name. And as a reminder, this is the bug that we're trying to catch, or this is the bug that happened. We were using an inner join, which meant that if we had a mobile review without any matching check-ins, we weren't counting it. If we had a mobile review with a matching check-in, we did count it. And what we wanted was the opposite. So let's take a look at this first test case. And we're going to try to write a test that is specific for this behavior. I'm changing the name of my test to test will count mobile reviews without matching check-ins. And I'm going to actually go into my input data to make it a little bit easier to refactor this test. This is the mobile reviews JSON. At the very, very bottom, in a second, there you go. You can see the row that is relevant for my test, but it's kind of hard to tell that this row is important. So I'm going to grab that business ID there and rename it to mobile review no check-ins so that I can more easily identify that I'm working with this row. That's that business ID is the primary key of the output table, so it'll come out with that same name. I'm going to run this test and make sure that it passes because I've changed things, and I want to draw your attention to this like green gem down in the bottom here. I'm going to be running a lot of tests. If you see a green gem like that, it means the test is passed. If you see a red X, it means that the test has failed. This test passed, which is great. That means I can start to change it. We'll start by looking at the anatomy of the test case. Most logic tests have 3 blocks: an arrange block, an act block, and an assert block. And we're going to start by changing that assert block. We want to make it super, super specific to the behavior we care about. First, I'm going to get rid of that comment. That's dangerous. Then I'm going to go and take a look at the data frame that we are testing. This is the actual data frame. And right now, we are verifying the entire thing. I don't care about the entire thing for this test case. I only care about that first row, that mobile review no check-ins row. So what I'm going to do is I'm going to add an index onto the end of my test case. So I'm just looking at that first row. But I don't even care about the whole first row. I actually just care about the business ID and the number of reviews. I care that the mobile review no check-ins row has a number of reviews count of 1 for this test case. So I'm not going to verify against JSON at all. I'm actually going to assert on the specific properties that I care about and map them to the values that I care about. Now, these 2 assertions are very specific to the behavior I care about. But when I work with my code, I like to be able to read it, and I like to be able to manipulate it easily. So I'm going to extract these 2 lines into a single line that's more clearly named. And then that single line is what I'm going to drop into the bottom of my test here. That's my assertion. And now my assertion is very, very specific to the behavior that I care about. And now I can actually start the squeezing part of the staff squeeze. So I'm going to take a look at that transform function. Right now, because we're calling the entire transform function, we are testing every single step that happens in that transform function. And not all of them are important to the behavior that we care about. So in order to identify the steps that are important, what we're going to do is something called an inline, where we copy the body of that function into our test case. Once we have inlined that code, we're going to grab our assertion and we're going to start walking it up 1 step at a time. Every time we walk it up, we're going to run our tests. Hey, look, that's the red X. Our test failed. That means that the line below our assertion is somehow important to that specific behavior. So we're going to move that line back below that assertion. And since I can't really tell what's going on in that construct post-pandemic recovery data frame method, I'm going to inline that as well, so I can see what the behavior is that I care about. And right away, I can see that the actual data frame is being assigned to the pandemic recovery data frame variable. So I'm just going to change the data frame that I'm asserting against and delete that assignment. And then I'm going to start walking up again, 1 step at a time, running my tests. Test passed. That means that the line below is just not important for that behavior. So I'm going to delete it from my test. I'm going to walk my assertion up 1 statement, run my tests. They pass. The line below it, it's not important. Let's get rid of it. And I'm just going to keep going, doing that all the way until I get another failure. Well, I can see that this is a join of the pandemic recovery data frame and the reviews data frame. And if I look at the error, what it's telling me is it's a key error. We're missing the number of reviews. So if I go take a look, if I print the schemas of these 2 data frames to just check what's going on in them, I can see right away that my pandemic recovery data frame has that business ID I care about, but it does not have a number of views. And the reviews data frame has both columns that I care about. And so since this is just a join, I'm just going to change the data frame I'm testing against again to test against the reviews data frame, move my assertion up one more statement, run my tests, and they pass. So now I can delete that line. I'm still making the assertion more specific. Keep walking up one line at a time, running my tests and checking that they pass. If they pass, the behavior is not important. I'm going to keep going all the way until I get another failure. Well, this is the count reviews function, so let's go take a look at it. And when I do that, I see something really cool. That's the join. That's the join that was missing that additional parameter. That was the source of my bug. I can't squeeze up from the bottom anymore. So now it's time for me to start squeezing the top. And squeezing the top is probably more accurately called simplifying the top. What you're doing is trying to eliminate anything from your inputs that you don't need to verify the behavior you care about. Right away, my IDE has indicated to me that I am not using my tips or business data frames. So I'm just going to delete them. And then if I look at this, I notice a little bit of a weird thing because we're generating the check-in data frame. And that's actually part of the ACT portion of my test because it's running code in my system under test. Usually when you have an ACT portion to a logic test, you want to only be testing one thing at a time. But there's an easy way to get rid of this because as a reminder, what we're testing is that you want a mobile review without matching check-ins. So all that I really need to do is create an empty data frame and use that for my check-in data frame. And now my check-in data frame is not running code under test, but it's still generating input that is valid for the behavior that I'm testing. I'm going to, now that I've replaced that check-in data frame, I don't need to read from that check-in JSON file, which has the added benefit of eliminating all the check-ins that I don't care about for this test. And now I only have one statement in the ACT portion of my test. I'm only testing one behavior in my system under test. Another cool thing that I can do is because we are only testing mobile reviews without check-ins, I don't care about browser reviews. So I can also stop reading in all of those browser reviews and replace them with the empty data frame. And that means that the last thing that I have to do is generate the absolute minimum amount of data that I need to count reviews in my mobile reviews data frame. And I only need one mobile review that doesn't have a matching check-in. So I've put that into my review list here, and I use that to create my mobile reviews data frame. That was a lot of work, but that was a simpler test. Question I get a lot when I make quality improvements is it worth it? And that is a hard question to answer. The reason it's so hard is because of the 0 to 1 phenomenon, or one of the reasons it's so hard is because of the 0 to 1 phenomenon. And the idea is that like the first time you make a quality improvement, the first time you make a change, you are learning. Not only are you learning, you're also building infrastructure that will help support you in making that quality improvement. So the first time you do it, it can take a lot longer than any of the subsequent times. So the way that one of the tests that you can use to figure out if a quality improvement was worth it is to try and make the same change again. So we're going to try and write a more specific test again. Thankfully, we have a second test case to verify that the behavior we care about is accurate. And that second test case is that one mobile review with a matching check-in does not count as any reviews. So what I'm going to do is I'm going to start by duplicating the test that I just wrote. I'm going to make the name more specific. So we're going to test mobile reviews count with check-ins. And then I'm going to go and make the assertion specific. We're looking at, for the old test, we were looking at having a count of one review. And we're going to change that one review into no reviews because we now have a mobile review that matches a check-in. When I do that, the test fails because I haven't changed anything in the body of my test. So I need to update it. I'm going to start by renaming that review input to matching on, because those are the values I want to use to match my check-in. And then I'm going to grab my check-in data frame. And instead of initializing it as an empty data frame, I'm going to initialize it with those matching on values. So now we have a mobile review that matches a check-in. If I run my test now, they pass. And that was a lot simpler. So I may have made it sound like at Yelp, we have a bunch of tiny little bug-specific tests all throughout our code base, and that we don't have that large logic test anymore. That is not the case. We are always learning new ways to test data. Sometimes we're developing new ways ourselves. So we still have that large logic test in place. But the SAF squeeze is one of the tools that we use to try and test our code more efficiently. And sometimes when I talk to people about these bug-specific tests, one of the questions that I get is, well, if you have hundreds of tiny little tests testing your code, like, isn't that a nightmare to make any changes? And my answer to that is these tests are so specific that the only way they fail is if the behavior that you're testing for fails or changes. And that really only happens in one of two cases. The first one is if you have a bug and you want your test to fail. And the second one is if you've changed that behavior without changing your test first, in which case you should really change your test. I had a feature that was covered with 20 tests, and I had to make a change in it, and I only had to update 2 of them because these tests are so specific to what they're testing for. These are my talk resources. Again, I promised to post this slide. And if I go to my thank you slide, they are up in the top right corner there. And yes, now I can take questions if anyone has a question.
Excellent. Excellent. Thank you. I'll just go with there were a couple that I recorded in the chat, and and then we can kind of ask any others. Amitai said, what's the fancy font with the fabulous Fs in this code?
Wait, what?
What's the font? There's a
the
fancy
Fs.
font with the Fs.
The fancy font, sorry, the fancy font or the fancy F, sorry.
The fancy font. What's the font that has the nice Fs?
Oh, I don't know, actually.
Oh, okay.
I was using a Databricks font, and then I had to switch these to not be branded for Databricks. So I forget which font I used, but I can probably send something to you after when I grab my, actually I can stop sharing right now and take a look at my PowerPoint and tell you.
Okay, that's fine. That was just a question. And then the Sherry was asking, why is the comment to actual DF dangerous?
Oh, because it is tempting. Like that comment, if you uncomment it, will actually run code that will overwrite your data frame. And so like that will overwrite your expected data frame. So having that in my assertion when I don't need it there is just, somebody could accidentally uncomment it and then overwrite something that I don't want them to. So I just make it safer by deleting unused commented out code. I have a saying like dead code is dangerous.
Yep.
And I try to get rid of it as much as possible.
Yeah. I love that. I love the deleting. I love the move up and then delete, and then, starting from the top and deleting down, all that, like anytime you can delete. That's excellent. Cody, you have your hand up. You have a question?
Yeah. So you said in the beginning of the talk, and I've also worked with big data and using PySpark before, and yeah, it can be very slow running even with small data sets. So what I'm curious about is, as you're making these smaller tests, which are way easier to validate specific behaviors, how have you managed the problems of like performance, like the test being slow and taking a long time?
So there's a few things that we do, because eventually I would like to be able to abstract away Spark and then just stick whatever I want behind there. But right now we haven't figured out how to do that. So Yeah, so originally that large test actually took about 1.5 minutes to run. The smaller test takes 6 seconds, so 6 to 10 seconds, depending on what they're doing, which is still a lot longer than what I'm used to in application development, but it is significantly better. We run our tests in parallel, and then so that helps a little bit because you've broken that large test up into a bunch of smaller ones, but that only helps so much. At some point, that parallelization cost starts to bite you again. So the other thing that we do is, as you're TDDing a feature, you do it in, or as I'm TDDing a feature, because I'm probably the one that cares the most about fast tests because I do the TDD on it, is because I will take a function and I will test that function as a single unit on its own. And because I'm only running, say, 5 or 10 tests for that specific function, and that's the only place that I'm changing things, I'm usually okay to iterate quickly with that. And then once I think the function is doing what I want it to do, I do a full suite of tests. And the full suite of tests still takes, like, depending on which full suite I run, the full suite can take 2 to 3 minutes, or 10 minutes if we're doing a full, like, static check, everything looks exactly the way it's supposed to and conforms to Yelp's coding standards sort of check. Yeah, but basically I just pull the pieces out that I'm testing for.
Mm-hmm. Yeah, and I've done that in the past before. I'm trying to remember what. It's been a while since I've worked with Spark, but at least with doing like right now, I'm doing some React Native programming, unfortunately. But the tests are kind of slow, so I think there's kind of we've reached a threshold where it's like I don't want to wait 15 seconds for all these tests to run, so I'm going to run a subset of them, and then before I check in or when I want more feedback, I'll run them all. So. But cool, yeah. I actually 6 seconds isn't that bad for what? Yeah, I guess what Spark's doing. I mean, it could be better, but that's actually not terrible.
It could be better. Spark is coming out with a thing eventually. They just announced it as like a pre-release in June. It's called Spark Connect, which basically is like a layer that sits between your code running on your local machine and a Spark cluster that's actually already existing in the cloud. And so, according to them, it is a lot faster than what we can do with Spark on our local machines at the moment. So we'll see. It might be a significant improvement to testability. Otherwise, I am going to crack being able to pull us out from that data frame API. And then,
yeah. Smart idea. Awesome. Thank you.
Yeah, no worries.
Other questions, comments? I enjoy that a lot. I kind of mentioned that earlier. I haven't done a lot of like data work, especially, well, not big data. And it's still interesting to see that we can sort of set up, set up our data sets so that we can still test it even when we're supposed to be dealing with these huge chunks of data, we can still sort of make it small enough that it's we can, how do I say, like very narrowly define our inputs and outputs. Let's see, Sherry had another question in the chat about, can you clarify this subtle difference? Is bottom up deleting lines of code and the top down? Let's see, is the bottom up deleting lines of code and the bottom down deleting parameters?
Yeah, so the bottom up is removing lines of code, and then it depends on whether the top down is deleting lines of code or deleting parameters. I didn't go into a lot of detail, but essentially I set up this example so that it would be really easy to do stop motion animation in a talk. There are a bunch of different refactorings that I would do with my code at the top to try and make it more specific. One of the things that could happen is I could have multiple lines of code from that inline function above the bottom behavior. And so then I've got to figure out, should I regroup the code so that it's closer to where it matters, or do I need to, pull out and cache values that I can then pass into the test? And in that case, from top down, I would be deleting lines of code as well. But for this case, I didn't. Yeah.
What do you use for an IDE? Are you using like PyCharm or?
I use PyCharm.
Mhm.
Yeah.
So it does most of these automated refactorings for you. Okay.
It does. It does, but you always have to double check your code with it, because it is not like, it is pretty good, but it is not as reliable as like if I was working in another language that had better type checking. Yeah.
One of the great things about refactoring in test code is that you typically have great test coverage. Do I need to explain? Is it like the too short version? The more detailed version is most of my experience is most of the production code that I have has intermittent test coverage. And so I never know if the change I'm making is going to be protected by tests. So this question of do I have a type system or an IDE that can refactor safely in that code, that matters a lot. But in test code, typically my test code is really well executed by test by itself. And so if I can't count on the type system or tools to refactor safely, I'm not as worried about it, because I know that test is going to run and give me an answer most of the time. There is still a risk there in that you can accidentally end up with a test that always passes no matter what. Like if you accidentally delete an assertion, that worries me. But a lot of the other risks around refactoring are mitigated in test code because the tests verify themselves.
Yeah, I've been doing a lot of refactoring in test code this past 2 days, and being able to run the tests has made a difference with that, to make sure that I actually am at least still testing the same stuff that the test code was testing, and now I have better coverage. So that's good.
Excellent. More from the chat. Sherry's asking, is if there's a third way to test, how do you tell the difference with that versus the bottom up and top down approaches?
I'm not quite sure what the third way to test means.
Okay. Maybe Sherry, can you kind of state that a little better, or we could. Why don't we move on to Jun asked, says, I'm new to Spark. I'm curious about how to test your Spark code. How do you test your Spark code? You run Spark using local mode or using Spark clusters? So you're welcome to speak to that yourself.
Yeah,
Jun?
we have we use local mode for a lot of our tests. You can actually, if you take a peek at my talk resources, I'll put up the slide again. I have a link to the code that I use to build these examples, and I actually have a working, running local setup for my tests for Spark in there if you want to take a look. So I'll share my screen again.
Also, I want to invite everybody to raise their hand and ask directly if they wish, or if not, you
I'm
can put them
super
in the-
friendly. Yeah, so if you want to take a picture of that QR code, or that go to that GitHub link, you can go and it'll give you a link to the repository that I use for these code samples, and you can see how I set up my Spark and everything for that.
Okay, thank you. Also, I have a question. You mentioned you did the test with the local mode. So is that the reason why the performance will be a concern? If we can run it like a cluster, maybe the performance will be better?
I don't think so, because what you'd have to do is you'd have to start up a Spark job. You'd have to start those clusters running, and then you'd still have that coordination overhead, especially if the clusters were too big for the test that you were running.
Okay.
The idea of Spark Connect is supposed to be that they have something that's always on, so you don't pay that startup cost, and it just immediately sort of connects to it. I don't know. We'll see. It would be fun.
Okay. Yeah, that sounds good. Another question is, which cluster do you normally use? You use like a AWS, like a EMR, or Azure?
AWS.
Oh, AWS. Okay, good. And do you ever have a chance to compare like a EMR and Azure HD Insight?
So we don't use EMR on AWS. We use Kubernetes on AWS.
Oh, Kubernetes. Okay.
We haven't. We don't use Azure at all at Yelp, and so I haven't really.
Okay. Okay, got it.
I do know that the Kubernetes on AWS is way faster than the EMR stuff.
Oh, okay.
Kubernetes on Spot instances is way faster than using EMR.
Okay, got it. Thank you.
Thank you for your questions.
Thank you.
Good. Other questions, comments?
One thing I'm curious about too, because this is always like if we go back to what that bug actually was, which was it was, the anti-left join versus an inner join.
Yeah.
As soon as I saw that bug, I'm like, is that? I guess you talked to the product owner, so you kind of knew that was the behavior you wanted. But I guess what I'm getting at is, now with the knowledge that you have about being able to write these smaller tests, would you have, if you had just talked to the product owner, is that where you'd start today? Like, hey, I know this, or do you think this still would have maybe slipped through the cracks because it's such a kind of small little join that's hard to.
I think it might, like, with the smaller tests, it would have been a lot easier to identify, hey, there's something up with this behavior, especially because writing the smaller tests and writing them first forces me to think about, like, what is the behavior? What are the specific things that need to happen for this behavior to occur, right? Because like this was one requirement from our product owner, is that we aren't counting mobile reviews that match check-ins, but that's broken down into 2 tests. And so thinking about those things very specifically is, it would maybe have just prevented the bug from being written in the first place. But because we just had that one large test, I think we didn't write as good of a test as we could have. And so we didn't cover all of the behavior we cared about. And so then we just wound up overwriting things into our test file. Yeah.
Can you just can you define anti-join?
Yeah, I will pull up that slide. So.
And as I'm getting at, is that joins are very confusing. Thinking about it hurts my head sometimes. So that's why the smaller tests seem awesome for this.
Yeah, which is also kind of what makes data code a little bit of a nightmare to test. Because like a single line can have sometimes multiple tests that you need just to verify the behavior of that single line. And so you're like, why am I writing so many tests for this small amount of code? But that's the way you get the behavior sort of verified. Yeah, so a left anti-join is what we have on the left here. It's basically, we'll take 2 sets of data and remove from the first set anything that matches the second set. And in this case, we have passed in user ID, business ID, and date as the columns that we want to match on. An inner join is the opposite. It's where you join 2 tables and you get back the matching values between them. So the left anti-join is what we wanted, which was on the left. And the inner join is what we did because we were in a rush and we didn't have tests that were easy to write. Yeah.
Excellent.
I guess last question too. now that it sounds like the team and maybe a bunch of the organization, this is a great learning experience. Has everybody shifted now to start writing like smaller tests first? And
Smaller tests, not all of them are writing tests first. So data code is interesting. Basically, when I started working in data code from application engineering, I had a bunch of people tell me, you can't TDD in data code. And sometimes when I gave this talk to people who worked in data, the answer that I got from them was, oh, you can unit test your PySpark jobs? Like that's what they took away from it, was that you could unit test data code. So there are a bunch of different skill levels on my team, and I believe in teaching micro skills. So nobody is writing JSON-based tests anymore. We'll start with that. That large JSON test is not being added to. But the tests that are being written are various sizes. And right now, I'm probably the only one on my team with the skill to write tests first, because I haven't had a chance to share how to do the refactoring and how to specify the behavior and how to break a feature down into individual tests and how to decide what the next test you want to write is in order to build the code that you care about. Yeah. A left anti-join is not the same as a left join. So a left anti-join would exclude things from the, I'm going to present the slide again because I need to point at things because joins are confusing. And I can see why you would have, all right. All right, so for a left anti-join, you exclude everything from that left data set that exists in the right data set. A left join is kind of like the opposite of that. So you're going to include everything in that left data set, but you're also going to join it and add on data from the right data set that matches any of the rows in the left data set. So it's almost like an addition. So if I did a left join with these tables, I would get all of the mobile reviews and the check-ins that matched on it, that match those mobile reviews, and the information from the check-ins that match those mobile reviews.
Michael asked.
Fair to say. Oh, sorry. So go ahead.
I was going to say, Michael asked if your teams have problems maintaining the tests because you're using the JSON objects, and then I actually does the structure ever change that you have to go back and redo the whole JSON files stuff? And
yes.
then I would sort of add to that and ask if there's a movement to get away from using the JSON.
There definitely is a movement to get away from using the JSON tests. And yes, they are hard to maintain. And they even have the additional annoyance of not verifying schema types, which means that sometimes the types of our schemas can be off and we don't know it. Which means that sometimes when you're outputting something back into your data lake, you're getting it out in the wrong format. So yeah, they are annoying, they're large, but they do still provide us value right now because they have that 100% coverage. We're moving away from them where we're working in the code. As we're working with the code, if we stopped to rewrite everything that's covered in those JSON tests with with proper smaller tests, then we would stop delivering features for like 6 months, which would not be cool. So we're maintaining those because they still provide us value, but we're slowly moving away from them, and there are no new tests being written with JSON. Yeah. Excellent.
It says here that you enjoy puns, and I didn't hear any.
I'm sorry. I'm not the type of person that can think of them off the top of my head. Yes, I do enjoy puns.
That's fine. So you run the Calgary Crafters Meetup?
The Calgary Software Crafters Meetup.
Thank you. And you want to tell us what do you guys have coming up?
Yeah, so we are starting, we do a monthly kata challenge in our Discord server. And what we do is we post a kata at the beginning of a month, and everybody starts working on it in their teams or in pairs. And we talk on Discord about what our learnings are, and people will open up ensembles for people to work with them, or open up a pair. They'll be like, hey, I don't want an ensemble, but I want a pair to work on this with me, and they'll volunteer. So we've got that happening. I guess I can share the link to our Discord server if anybody wants to join that. And then we are planning on hosting the Global Day of Code Retreat coming up at the beginning of November. And I'm not planning that one, but the people on my team who are planning it are thinking of doing it as a hybrid thing. So you should get a good experience remotely, as well as if you came to Calgary in person, that'd be awesome. Just let me know that you're coming and I'll make sure to like show you around.
All right, I heard that. Everybody heard that.
Or I'll try to. Maybe I might not be around, but if I am around, I will try to show you around. Yeah. Let me open up my Discord.
Excellent. And while you're doing that, I'm going to post a link to our Seattle Code Crafters Slack channel. If you're not a member, please feel free to join us and continue these conversations. I also want to talk about next month. Tara Scott is going to be joining us, talking about, it's called You Do You. It's your best stuff in psychologically safe environments. That's going to be an excellent talk again, October 27th. So fourth Thursday of the month. And you have that link, Jacqueline?
I do, yeah. It's just, it didn't copy the first time. Oh, sorry. I not send that to the channel. There we go. There's the Discord link.
Excellent. So I'm going to wrap up here unless we have any last minute, like, oh my gosh, I have to know this answer to this question. Thank you very much. That was fabulous. I really enjoyed that. Learned a bit, which is always the outcome that I wish to have at our crafter meetups.
Nice.
Yeah. And I want to thank everybody for attending. I did record this. It will be online in a couple days. It'll be in the Seattle Code Crafter, the Seattle Code Crafter Meetup YouTube channel, and you'll be able to either search it or we'll put the link in the Meetup group. So, all right, thank you all, and have a great day.
Thank you so much. I appreciate it.